Okay, so good day everyone. So today we will be solving problem number 5 now for our course Thermodynamics 1, Chapter 1, Basic Principles, Concepts and Definition. So the mass of air in a room 3 by 5 by 20 meters is known to be 350 kilograms. Determine the density, specific volume, and the specific weight of the air. Okay, so in this case, we have the provided answer key, and let us find out now if we can get these values. Okay, so first we will write down the given. So given, sorry, so given is, as you can see, this is a dimension, 3 by 5 by 20, and this is a three-dimensional given, so therefore we can say that this is a volume. So volume is equal to 3 meters by 5 meters by 20 meters. Okay, so we will compute uh, our dimension so that we can get the actual volume. So 3 times 5 times 20 is 300. So therefore, the volume is 300 cubic meter. Okay. The next one is the mass, which is 350 kilograms. Okay. So no more given now. So we will go to the requirements. So in this case, we have three unknowns. No. So we will solve for the density, the specific volume, and the specific weight. Okay, so for the solution, now let's start first with the density. So for density, we have the formula of mass over volume. So mass is 350 kilograms divided by the volume, which is 300 cubic meters. Okay, so therefore our density is equal to so 350 divided by 300. So as you can see, the answer is 1.1667. So 1.1667 kilograms per cubic meter. Okay, so this is our first answer. Okay. Okay, so next is our specific volume. So for specific volume, we have the formula of 1 over density, because specific volume is the reciprocal of the density. So substituting, we have 1 over 1.1667 kilograms per cubic meter. Okay, so 1 divided by 1.1667. So the answer is 0.8571. Okay, so the cubic meter is transferred in the numerator, so our unit becomes cubic meter per kilogram. Okay, so this is our answer. Okay, okay, so after that, now we can also use alternative solutions. Okay, so alternative solution, or the alternate solution, I should say. So alternate solution, we can solve for the specific volume now using this formula. Now specific volume is equal to volume over mass. Okay, so based on our previous given, volume is equal to 300 cubic meter. over the mass, which is 350 kilograms. So therefore, our specific volume is equal to, so 300 divided by 350. So the answer is the same now as above. That is 0.8571 cubic meter per kilogram. Okay? So you can use any of which, no, that you would like to use. This will still yield to the same answer. Okay? So the next one is the specific weight. Okay? So for the specific weight, we have the formula of weight over volume. In this case, now we don't have the given weight, but we have the given mass. So we will apply, or we will use mass instead, no, by having mass times gravity. Okay? So mass times gravity divided by volume. So substituting, we have 350 kilograms times the gravity, which is 9.81 meters per second square. Okay? So divided by volume. So our volume is 0.8571 cubic meter per kilogram. Oh, I made this wrong. So sorry, now the volume is actually 300. So 300 cubic meters. Okay? So let us solve this. So 350 times 9.81 divided by 300. Okay? So the answer is 11.445. So this is newtons per cubic meter. Because 1 newton is equal to 1 kilogram meter per second square. Okay? Or if you want, no, you can apply cancellation of units. Okay? So let's go back to the numerator. So 1 newton is equal to 1 kilogram meter per second square. Okay? So we can cancel the units. So kilograms, meters, second square. So the remaining unit is in Newton. So therefore, no, we can say that um, the answer is 11.445 Newton per cubic meter. So let me highlight the answer key for you. Okay. So if the specific volume has its alternate solution, no, specific weight also has it. Okay, so alternate solution. So going back to our formula, which is weight over volume, no, we can have mass, gravity over volume. And as you can see, now we have m over v, which is equal to our density, right? So therefore, you can say that specific weight is equal to density times gravity. Okay? So substituting, we have the density is 1.1667 kilograms per cubic meter. And then our gravity, which is 9.81 meters per second square. Okay? So again, we have 1 newton is equal to 1 kilogram meter per second square. So cancel of units. Okay. So therefore, our specific weight is, if we try to compute in our calculator, we have 1.1667 times 9.81. Okay. So as you can see, no, it yields to the same answer. So 445 Newton per cubic meter. Okay.